Welcome. This is Unite 2011, fifth Unite conference ever, also the largest one, of course. It's wonderful to have you with us. We have a lot of stuff going on. We have 1,200 people signed up this year, which is a lot of people. Thanks for coming. We have a lot of sessions. We have 41 sessions given by 70 speakers, covering pretty much every aspect of Unity. So hopefully you'll come and you'll be able to learn what you want this time. We have 12 hours of hands-on sessions. That's, of course, our favorite format, where we expose all our engineers to sit with you with your laptop, for half an hour, talking about your project, helping you. You can sign up. We have sign-up sheets based on categories. You can sign up for networking problems, mobile optimization, consoles, et cetera, et cetera. We also have a business speed dating session on Friday, where you can meet new business partners, publishers, studios, hopefully people you can hire, work with, their service providers. We have a number of sponsors who are showing their stuff here, and you will also be able to meet with them, of course, during the entire 3 days. Thursday evening, we have the Unity Awards. We had over 100 nominees this year, some pretty freaking incredible games, and we're looking forward to showing you which of these won. Now, the fifth Unite, that means that 4 years ago, the first Unite ran, same time of year, in San Francisco that time also. Back then we had 70 people in a much smaller place. We still considered it a success. It was incredible. Back then, by the way, we were only 8 people in the company, plus a couple of interns who we counted to kind of, boost the numbers. And actually, one of them is working with us now, of course. And the amazing thing when I think back is what business did a company of 8 people have to run a worldwide developer conference in a remote city? We were back then, of course, based in Denmark. We were so underfunded. I remember we couldn't pay our catering bills for months afterwards. It was a big embarrassment for us. And sorry to the caterers back then. It felt really bad. They needed the money. But we didn't have it. So what business did that company have of running a worldwide developer conference? And I was kind of thinking back, and I think the only answer is that we always believed and felt that Unity had to be really big in order to sort of fulfill its mission of democratizing game development. And we've always kind of been, thinking bigger than we were and acting bigger than we were. And I think, we were then joined by wonderful team members who kind of understood that and helped us with that. The community has always been part of understanding that, also bearing with our shortcomings as we grew. If there's anything, any reason why we're here, that's it. And then I was thinking this, and I thought slightly further back. And I remembered when we were 3 developers, programmers in a basement, and we were coding, and this is 2003. We were visited by a venture capitalist, a guy who builds technology companies. And he came to our basement, and he sat down on the chair we gave him. And he listened to our story of democratizing game development and how we wanted to take the most advanced gaming development technology in the world and package it up in a way that anyone could use it. And he kind of politely heard us out for 2 hours. And then afterwards, he sort of with slightly world-weary eyes told us that we should just know that from that point in the basement in 2003 to, well, I guess we can say here, the odds of actually getting there were approximately 1 to 1,000. And I think he actually I think he meant it as a heartfelt warning against doing these crazy things. But I don't think for a moment even we thought about giving up. And actually we used this symbol 1 to 1,000 as a sort of badge of honor, and we put it on our desktops and printed it out and kind of worked against it. Somehow it all worked out. So now we're in 2011, and everything's been growing really fast, right? The team has grown to 150 people. Engineering is the heart of the company. That's the team that grew the most in absolute numbers, from 39 to 64 people. That's a lot of brilliant engineers that have been joining us from all over the world. But also the other stuff, the marketing team has grown a lot, the sales team has grown a lot. Actually, if you look 1 year back, the sales team was 2 people, and 1 further year back, that was me, mainly. And the thing is that to sort of create an environment where the engineering team can really excel and can support you with all the stuff that you need, apparently you need to build a lot of infrastructure around it, and we've been doing that. And we feel that although we've made all kinds of mistakes along the way, that we're really getting there as a company. And we're still, by the way, hiring rockstar engineers and other cool people, so keep that in mind and tell your friends. Another thing that's been happening, actually only in the last year or so, is that we've become sort of truly global. Before that, we were always global, right? We had a website in English, and we sold our software. And a lot of people bought it. But the thing is that we found out as we grew that the world is actually bigger than that. So we started acting on that approximately a year ago, and now we have offices in Japan and Korea, and we're doing tech support and sales support in English, Japanese, Korean, and Mandarin. And this is, of course, only the beginning, but these are the sort of first markets we went to, and it's going really well. And of course, also in our hearts, we are just very multinational. There's 21 nationalities inside the company, it's kind of cool to come to work and work with all these people from different places. Another way we're international is, if you look at the left column, it's the countries where Unity is being used the most. So US is #1 still by a pretty significant margin, but then you have China, South Korea, you have Japan, the UK, and then it trails into a very, very long tail. And down there's actually Togo, there's Greenland, there's Antarctica, and it's kind of amazing to behold. On the right, you have the cities, and I only put it up there really because of the top 10 cities in the world where Unity is being used, I had to use a map to find one of them, and I can tell you that that Neihu is in Taiwan. So it's kind of amazing, right? I've never been to Taiwan, although some of our people have started traveling there and meeting the community there, and it's actually a pretty strong community. We have great partners there and so on. Anyway, we've also been getting a lot of awards. Like, people sort of recognize that Unity is, cool and maybe actually getting to be important. A year ago, we had sort of been gathering these awards in the previous year, some very prestigious things. And then in the last year, it kind of went crazy. So notably, we were awarded Best of Show at Game Developer Conference. Game Developer Magazine awarded us as the #1 engine. In Japan, the SEDEC conference awarded us as the best development environment, and actually a whole bunch of other stuff. So that's kind of amazing. And of course, the fact that you're using our software and showing the world what is possible with it is at least as important as what we do. So thanks for that. We've also been building a whole bunch of software, obviously. So we put out the full release of Android, released it March this year. It's already selling like half as well as our iPhone product, so a lot of people are making Android games and becoming successful with them. We always have a hard time counting, but we estimate around 200 games on Android, while, of course, our iPhone product is still kind of the leader of the pack, still going strong after 3 years. We were the first there. We're still by far the strongest. We estimate around 2,000 games, or probably more. We've counted 200 top 100 games, and a lot of top 10 and top 1 games. And we still have sort of a significant section of the top-selling games. Also, finally, after years of work, we can say this year that we support all 3 current-gen consoles. There's actually titles you can buy for all of them: PS3, Xbox 360, and the Wii. The last one was the last one was actually an Xbox 360 title that launched just a few days ago. And then, as always, we've just been hard at work improving, many improvements, right? So 4 dot releases in the last year, 1 billion optimizations, bug fixes, lots of workflows and polish. We put some very cool image effects that you can use for depth of field and blurs and glows and stuff like that. And then we put in the algorithmic substance technology, which, if you don't know it, you should go. There's a whole session about it, about how you can create textures from almost nothing, from photographs, tweak them, tune them, tile them. And you can also buy, I think, 650 of these substances in our store. So if you want to start with all kinds of surfaces, that's a very easy way to do that. So regarding the asset store, we launched it a year ago. And I'm actually going to ask co-founder Nicholas Francis to come and say a few words about it. Love it.
Morning, guys. All right. Thanks for coming. So 11 months ago, we launched the asset store. And it was at last year's Unite. So it's just about 11 months ago, and I'd like to sort of just take a quick look at sort of seeing what happened. When we launched it, or when we made it, our idea was really that when you need to make a game, there's such a diverse skill set you need to have. You need modelers, you need animators, you need programmers, you need sound guys, you need music. There's such a diverse thing. And this is okay if you're a large company, but if you're a smaller team, it's really nice to not have to be able to fill all these shoes. And even if you're a large company, it's quite nice to just be able to grab something somewhere. The Unity community has also been really good at helping each other, and I think that's one of the nicest things. We saw this early with the Unify wiki, but we figured that maybe now we could actually take it to the next level. So we launched this, and something truly magical happened. And basically, I'd like to just show you a few stats on this. And when you create a store like this, there's two metrics you care about. And the first one is how many packages are available. We want to have a large store. We want you to be able to find what you need on there. And if we take a look at it over time, you can see as of today, we have 1,860 packages. So it's been growing steadily, and we now have people full-time whose sole job it is to find new content out there and get it on the store. The other one is a very simple metric. That's how much money is going through the system, because that's a very good indicator of if a store is a success. And if we take a look at this month, we will go over $140,000 in sales. And we're so happy about this because this is a very real indicator that this thing is actually working, that our users are making money by making Unity assets. I'd like to take you through a few of the things we're doing. So the first thing we have is UScript. This is one of several graphical scripting languages on the Asset Store. It was developed by some of the guys who had a hand in designing Unreal Kismet. And what I love about this and the others is that it shows that it sort of changes the game a bit, because if you have a great idea for a game, or you're a great graphic artist, you no longer have to be a great programmer as well. And and even if you're a large team, you have a bunch of people who you just want to set up simple stuff. So you might have programmers that build complex stuff, and they tie into these systems. So I think it really changes what you can do. The other one sort of speaks a bit, is Rage Blind. And it speaks a bit to some of the things that I at least sort of didn't really expect with the Asset Store. And it was basically made by a Finnish guy who wanted to do a vector graphics game. And now, Unity didn't have the 2D vector graphics support he wanted, so he made his own little tool to edit them. He showed it to some people, and some people from the community talked him into putting it on the Asset Store. So he thought, okay, yeah, I'll try it, why not? And then he looked a few days later and saw, wow, this is actually making real money. So he spent a huge amount of time and energy polishing this, making it better, improving it, listening to user feedback, and just kept on making this better and better and better. So because of the Asset Store, now anyone can get really high quality 2D vector graphics inside Unity. And I think that is just sort of completely amazing. My last example is the Strumpy shader editor. This was made by this crazy Australian guy, and by day he was working on the next BioShock, and at night he was making games with one of his friends. This friend was a graphic artist, and he kept needing shaders to be written. So Stramit, or Tim as he's known in real life, he just thought, I'm just going to make a tool to do that. And after he made this tool, he released it for free on the Asset Store. And we'd had other packages selling from day one, but they just got nuked by this tool because it was free and it was awesome. And in fact, it was so awesome that we had to go out and hire him because, yeah, he clearly knew his stuff. So one of the things that's sort of interesting is, can people actually make a living on the Asset Store? Because if that happens, that's really nice, because then you can actually have, then the Asset Store can become a medium for game developers servicing each other. And so I have like a few stats here. The first one is the top seller this month. Clicky, clicky, thank you. That will make over $20,000. I think that is a very real amount of money. The other one, but it's easy, of course, to like just say, hey, the top guys make a lot of money, right? We all know how that goes from the iPhone. So the other one is we took the top 15. And on average, they made over $5,000 a month. I think that is really good. Now, going forward, because The asset store, to me, is nowhere near done. When we launched it, we had no idea what we were getting into. And up until now, all payments have been processed by hand, and we've had people from accounting go into seedy back alleys to find obscure Western Union branches where they could sort of pay the money to you guys. And it's just been completely insane. And for those of you that have been really frustrated with sort of saying, where's my money? They promised I'd have it. I do apologize. We've been doing everything we can. But now we actually have like our infrastructure in place. And so from this month, everybody who gets a PayPal, they get it every month. We'll need any charges, it should just run automatically now. And I think that's really nice because we don't like to sit on your money because, well, it's your money and, yeah, we have to pay it out to you anyways, we might as well get it over with. So, the other thing we're doing is we're doing a much, much deeper integration into Unity of the asset store. Because I think that when you want to buy art assets, there's a lot to be said for seeing it in the environment that you're used to working in. And so, we're launching the object browser. This will come in 3.5. It is a unified view of your project. It shows all assets you have. You can filter it by type, by tags. You can do searches. And it will show everything in your project. At the bottom, there's two collapsible bars. One is for paid assets, the other is for free assets. So any search you do, you'll also see what we have on the asset server. If you don't like it, you think we're spamming you, just collapse them, and these two bars will live in infamy sort of at the bottom of a very long scroll window forever. We won't mind. But I mean, even the free asset, that actually makes it very easy for us to provide high-quality default assets to you guys you can just get when you need them, rather than having to install everything together with your projects and your standard assets. The other thing is that when you select things down here, we actually show them in the inspector. If you're listening to audio, you can hear it before you buy. If you're looking at a model, then you can actually see how the topology is before you download. If you're looking at substances, you get all the parameters you can tweak. You know exactly what you're getting. And I think this is really going to take, so this sort of smooth interaction is going to take this to the next level. And yeah, and that's sort of what we're doing for Asset Store. In a way, this leads me into the next subject. And for that, I'd like to take a step back. And let's take a look at what Unity sort of basically have always been doing and what we're focused on. Essentially, we want to make it possible for everyone to create games, from the hobbyist that just got started to the seasoned AAA veteran. And essentially, that's what the Unity toolset is. We want to make easy-to-use tools that can take you far. But then, at some point, we took a step back and thought there must be more to it than this. There's other problems to solve. And then we thought, well, the asset store is kind of an answer to that. Because we thought, maybe there's something to make games that's more just assembling bits and pieces. What if everybody didn't have to model the same palm tree over and over and over? And that's sort of the asset store. It extends on this idea. But so once we started thinking like this, we decided to take it a bit further and say, well, can we do more? Instead of just making an awesome tool and make it possible for people to create great games, what can we do to make them be successful game developers? And that's a lot larger problem to solve. And part of this answer, our answer to this, was Union. We got so many calls from weird hardware vendors that really wanted to get games. So I thought, okay, we'll create a service for that. But I think there's a far, far bigger thing we can be doing. And that is basically, instead of looking at what's around the editor, and in union with the business side, that's looking what's running around a game. Because these things are changing, and they're changing fast. And I think we need tools for this. So the first thing we're doing, this is like a forward-going initiative. So you'll be hearing lots of updates about this, but I wanted to sort of show it to you now so you sort of can see what we're thinking about, where we're heading. And the first one is a social API. It's friends, achievements, leaderboards, come on, thank you. All the usual stuff. And it's one API, and it's completely cross-platform. Now, the first one we're launching, and this is in 3.5, that's iOS Game Center integration. The nice thing, and we're also at the same time working on Facebook, and that will launch sometime after 3.5. So again, it's the same API, you just go to either place. Finally, on consoles, it will just map to their native platforms. Because really, you don't want to rewrite this code. It's not very interesting to write in the first place. The nice thing about this is that it's a completely pluggable backend. So if somebody out there, say OpenFaint or someone, just wants to have a lot of Unity games using their stuff, they just have to provide the backend for this API. It's a very simple API. And that's sort of the first thing. And on web player, we'll find some way of making that work as well, if you're just somewhere on the web. So the next thing we want to talk about is analytics. Analytics are interesting. Everybody thinks they should be doing it. Very few people are. And basically everybody's saying it's also the key to monetize content. The reason they're saying it is because they're right. You actually want to know what's going on with your game. You don't just want to think about it. So analytics are very important if you want to generate revenue, especially if you're doing more than selling your game once, and that's it. Even if you're selling your game once, all the large studios are using analytics to make sure their games are interesting. And that's a fun thing, because analytics can be used for far, far more than just revenue. I have a small example of this. Guess you all know Angry Birds. This was, we have this door in Angry Birds, and it's very simple. It's a red door, that means it's locked. When you see it, you have to follow the red power line to find a switch, and then the power line turns green, so you have to go back and go through the door. And I was seeing people trying this in our office. And I was saying, can people actually figure out that they have to follow the red power line? Because everybody seemed to go out of play mode just when they got to that door. Cool, yeah, please stay at slides. And essentially, what if, and it was sort of but they got it eventually, at least after we told them. But what if instead of just we never fixed it because there was just one guy who had this opinion. What if instead of that, we'd had something like this, where we could actually see in the editor, how are people interacting with our game? I think this is incredibly important. And one thing is heat maps for how people are playing, but it's also where do they quit? Where do they die? Where do they die often in a row? And even more interesting, where do they quit and never come back? All these things I think we can track, but it requires a back end. And most people, if most game developers, they're really great at making games, but the moment they have to configure a server, they will go do anything to avoid that. So this is the next stuff we'll be doing. It's basically analytics. And first part of this is what I call zero-day analytics. It's not something you should latch on to the end when you're just about to ship your game the night before it goes live on the App Store. It is something that can help us make better games right from the very beginning. When you have a test build, you give it to 3 friends, and you let them play on the phone. You actually want to know these things. Because if you can find a frustrating spot early, or realize, hey, no one's actually getting to 75% of my game because they all take this wrong turn here. That is a tremendously valuable thing to know, and you want to get that early. The other thing is, it should be completely integrated into Unity. It's a simple API, and you just pull it up inside the editor. So you just always see what's going on, what's doing, what happened in the last 24 hours in my game. And the last thing is that we'll be hosting it. Basically because no one likes to set up an analytics server. And it doesn't make sense for thousands of game developers to be worrying about how do I make this scale in case my game is a hit. We can assume that at any one time, there will be a few Unity hits that are getting a ton of playthrough. And here we're talking thousands of events per second. And we can build this to scale it, and then we can spread it out. So that's the analytics bit. The last thing I want to talk about is our third piece of this puzzle, and that's in-app purchase. And there's a fun detail about in-app purchase that I didn't know about. And that is, we all know Infinity Blade. It's a core gamer experience. It is not a cheap game. Yet, they still make 40% of all their revenue selling swords to people. So in-app purchase doesn't have to mean that you're doing free-for-play Smurfberry games. You can do it in a lot of games, and there's just something you can do to get a bit more money down the line. And I think that's tremendously valuable. And again, for in-app purchase to work, we want to build a cross-platform. You'll have one API. On iOS, we'll target this. We'll just target Apple. On consoles, it'll work with them. Now, the next thing is it needs to be tied into analytics and all the social backends. You can see, hey, it turns out that these people here, there might be a bunch of people giving up here, but a lot of them got them by the sword. So maybe there's some trade-off you can do that. You want to know this. You don't just want to like throw things at a wall and hope people buy them. You also want, with the social stuff, you want to see, okay, if I actually pay people through some ads to play my game, will they get their friends to play it? Does this make sense in the end? And the last thing is to integrate it with the editor. I think you're sort of getting a meme here. And essentially, it shouldn't be something where you like have to write scripts where you like say, hey, this asset button goes up here and you configure in a server. It's like, no, take this folder. This is the asset you're actually buying. It costs $15, or it costs $1, or whatever it costs. And then, at build time, we want to make this work for you. And we want to, when you just run your store in your game, you can actually see all this data. So you're always in the flow, because doing these things shouldn't be hard. They're not really hard problems to solve. They're just really annoying to solve. And that is why we think that you guys shouldn't be doing this. We should. Now, this is not something that we'll be shipping just around the corner. This is sort of a more long-stretch thing. But this is sort of what's very much on our minds. And yeah, I would like to say thank you.
So these two initiatives, the asset store and all these connected services, are almost as exciting as our third initiative, and actually the one that's been going on the longest. And we call it the AAA initiative. And it's basically based on this that, we started out 3 guys who didn't know better, and we built this product, and it was a great product. And then, later it actually worked. And and the team grew. But as we grew as a company and our stature in the market grew and more people started using Unity, it turned out that people wanted more. They wanted to push the technology harder. They wanted to work in bigger teams. And it turned out that Unity has fallen short in some things. And we realized this, well, we kind of always knew. But we realized around a year ago that we actually had the energy to go and fix this. So we recruited like crazy, recruited people from some of the, who were behind some of the leading AAA engines today. We just got, incredible teams. We set up a development office in Stockholm because there were great guys there that we had to have. And we've been working really hard. And it's actually coming to fruition. What's really important is, that beyond just setting new standards and pushing this, we also felt that Unity could not break. We couldn't fork it into 2 different products. And somehow everything we did had to benefit the broad range, not just some few teams that pushed Unity hard. The amazing thing is that it turns out that everything, or almost everything we're doing now to push this sort of high-end agenda benefits kind of everyone. And that's been, something that we felt was just totally key. One of the other things we realized was that we had to be working with teams that pushed Unity really hard. We decided not to become a game development studio. That would have been a natural avenue. Instead, we decided to engage with certain teams out there that were pushing Unity in interesting ways. We did this for our sake, not so much for theirs. So don't feel bad if we skipped you. We have to be extremely selective. We have 1 or 2 of these projects going at a time. We embed ourselves. We develop with those teams. And the technology is, of course, on our terms and goes back into the product. So there's 2 teams that I want to show you that we've worked with like that. The first one is a South African game studio called Luma Arcade. They've been working on a game called Blade Slinger for mobile. And we've been working with them, giving them access to some of our future Unity 3.5 bits and also learning how these bits should be. And this is a sort of a very early preview video. They feel a bit shy about showing it, but I think it shows kind of, the gist of where this is all going. So let's just watch. So, pretty awesome stuff. This one has far to go before it gets to the state that these guys will be proud of, but we know they'll get there. The other project, and this has been more public, you've heard about this before, is of course our very good friends at Madfinger Games out of the Czech Republic. They've been working on their Shadowgun for a while. Again, we embedded ourselves with them. We worked, we learned, we put a lot of technology back in Unity 3.5. And here's their video. The game launched on the App Store actually just a few hours ago, or 8 hours ago or so. This is the release trailer.
We strongly prefer you return Dr. Simon to us unharmed.
You assume this mission will be easy.
No worries. Charge more for this job.
Yeah. So both NVIDIA and Apple have agreed with us that this is by far the highest end game ever to run on a mobile device. We're very proud of them, and of course we're proud of our work that we've done to support this. There's more stuff in the pipeline, of course. One of the frontiers of high-end game technology is character animation. It turns out that it's very complex. It's extremely labor-intensive in the production side. But also for small and medium-sized teams, it's really hard to get right. Animators are expensive. It's hard to outsource animation. So animation has really been something we kind of worried about. So we were so lucky with this mindset to meet what I think we can say are the leading edge of character animation in real time. It's a company called Mechanim out of Montreal. It's a young technology startup. It's basically guys who worked on Motion Builder, Human IK. They worked with EA Sports, and so these are some of the top technologists in computer animation. They talked to us for a while. We thought about licensing their technology and putting it into Unity, but we sort of realized that we would get much more bang out of the buck if we actually acquired the company and brought them in. So we brought them in. It's our first acquisition. They are now Unity Canada. This is explicitly not ready to go into 3.5, but it will be in a future release, and you will be absolutely blown away. It's really both simplifying and pushing the boundaries in ways that are hard to imagine without having seen it. But anyway, you came here to see Unity, right? And Unity 3.5 is not ready to release, but this is the first time we show it outside. Joachim? Our very own CTO. Thank you, David.
So I just want to give you an overview of what we've been working on for Unity 3.5. And Unity 3.5 is really about scaling Unity up in various ways. So the most important one is Unity has always been working really great when you're a small team. And with Unity 3.5, we wanted to make sure that you have this really smooth process of working with Unity if you're a one-man team or if you're a 100-man team. So we built a lot of tools to make that, to make this workflow really nail it. The other thing is we really scaled up the graphics pipeline. We wanted to make sure that you can really render really big scenes. And we spent a lot of time performance optimizing and doing all those things to just do bigger projects and make things look a lot better. How do I slide? Next slide. No, wrong way. Sorry about that. Can we switch to the demo? Demo machine, please. Thank you. All right. So one feature we added is a level of detail support built into Unity. And this scene specifically is a scene with 70 million triangles in it. So we have level of details on these buildings. There's 20,000 buildings visible. So when you zoom out, you can see all these buildings here. And then when you zoom in, you can see these pretty high-resolution buildings. Each building has 3,000 triangles and is actually consisting of multiple renderers, multiple materials, and so on. And then we have a level of detail system built into Unity now where you can very easily make it run fast when it's further away. You just switch to a different level of detail and everything runs fast. So I just want to show you real quick how you set these things up in a smaller scene. So here we have one building. And you can see when I'm up close, I have this building here. I'll just select it. And you have this LOD group here. And now I can preview it. So I can see here this building for the level of detail 0, and it says 3 renderers, 3,000 triangles, 6 materials. Here's a lower detail version and the lowest detail version with just 300 triangles. And then you can preview it by just changing the slider here. You can change where it does the LOD switch exactly, like this. So everything is live previewed, and it's just really nicely integrated into Unity, and basically just works. One of the great things about the system that we did with the LOD is that it's based on renderers instead of just meshes. So if you want to, for example, make a cloth object for a close-up, like a hanging drape next to this house, then you can do that in the highest lot, and then further away, you switch it to to just a mesh, because it's so far away, it's not going to be visible that this is actually animating. So it lets you really combine level of detail in very interesting ways. So yeah, that's the level of detail feature built into Unity, and it really scales. You saw the scene with 20,000 buildings. Yeah, it's pretty cool. Can we go to the slides? Oh yeah, there we go. So the next feature we worked on is this is our first step into AI. So we built a fully integrated AI solution, and I think it's really pretty incredible. It has automatic nav mesh generation built into Unity, so we automatically generate these navigation meshes for you. There's a crowd simulation module built into it, and a lot of functionality to make AIs easier. So I have this really simple scene here. There's these couple of guys. There's the red guys, and there's the blue guys. The blue guys want to go to the blue flag, and the red guys want to go to the red flag. And it's this very simple scene, right? Now, what I do is I go to the navigation mesh, and I go here, and then I hit bake. And it's extremely fast. So what's happening is that it voxelizes the whole environment and generates this navigation mesh basically everywhere where your character can walk from this voxelized representation. And that's then the representation on which your characters walk. So you can also tweak things like this, like you can tweak the maximum slope on which they can walk. So if you want them over here, if you don't want them to walk down these slopes, you just change the maximum slope, you rebake, and then they're gone. And another really unique feature that we added is drop heights. So you see here these stairs, these ladders, and they can climb up on it. And you can place these so-called off-mesh links manually in Unity. So if you want to make a ladder, you can just make some custom animations for it and connect two arbitrary places in a navigation mesh. But you can also make them be generated automatically. So if I set the drop height to 2 in this case, and hit bake, then you can see here it generates all these links for jumps, basically, so that the agents can automatically jump down in these places. So I'm just going to hit play here and see how this actually looks. So now we have these agents walking around. They try to take the ladder, then they get occupied. The other guys take another route, and they end up at the goal. And all of this, and basically the API for this is extremely simple. You have this agent component, and it has all kinds of properties like the radius, the speed, acceleration, and you just call a function set destination point, and then it will just try to walk towards the destination, and that's it. On top of that, there's a lot of low-level functionality built into it, where you can sort of like sense your environment. You can do raycasts over the navigation mesh. You can figure out how far is the closest wall, and these kind of things, which are really useful when you're building an AI. So then we also have one of the really cool things in it is we have this crowd simulation system. And I really think this is one of the most beautiful looking crowd simulation systems I've ever seen. So I'll just show you this. This is one of the really difficult cases to handle when you have like these people walking in a sphere, crossing through each other, and they just handle it really nicely. So in our system, they actually anticipate where they will collide with each other, and they try to conserve energy when doing the crowd simulation so that it looks really realistic. And this is something that I'm not aware that any other engines actually have. So it's a really cool system for making crowds that look really realistic. So let's go to slides. So the next thing is we wanted to make sure that we can actually scale Unity projects. So when you're working in a team, a lot of people didn't want to use the asset server for a lot of reasons. So what we did is we made a fully integrated UI for Perforce and SVN. And it's very easy to use. It's completely integrated into the UI. And it's, you can just use it, and it makes it very easy to, like, if you want to rename your assets and so on, everything is just integrated. You can commit assets directly from inside Unity. So the next one is we made a new format for saving scenes and prefabs and these things. So the problem is often you want to... So you want to, often you really just want to work on the scene with multiple people. And how do you do that? So you have a text-based format, you have two people editing it, and then you merge the two things together. There's a lot of tools out there to make merging easy with text-based files, and it just works. And then lastly, when you're working in a big team and you have a really big project, let's say you have a project folder with 100,000 assets, 50 gigabytes of assets. Let's say you want to get a new project folder and import it. We had a customer who has such a project folder, and it takes them 10 hours to import it. Now, you can use a lot of tricks. You can just take that project folder and give it to your people in a sort of like pre-imported state. But it's not really how we want to roll, right? So we built this cache server technology. And essentially what it does is it's completely transparent to the user. But it figures out that if somebody has already imported an asset with that specific asset and that specific import settings, then it figures out that somebody has already imported that, and I'll just grab that and download it instead of importing it again. And on a project folder like AngryBots, when you import it for iPhone mode, it takes around 20 minutes to import from scratch. With the cache server, it takes 20 seconds. Yeah. So next up, I want to give a demo. So as many of you probably know, we had an occlusion culling system in Unity 3.0 as well, but there were a lot of problems with it. So some of the problems were that it took a lot of time to bake the occlusion culling data. The second problem was that it was sometimes inaccurate, and you couldn't figure out why. And truth be told, I mean, it was just a little bit buggy. So we fixed all of that. What we actually did is it's been completely rewritten, and it uses a completely different technique. The new technique in this occlusion culling system both adds a couple of new features and also makes it a lot faster to bake. Can we go to the demo machine? Thank you. So I have this very simple scene here. There's all these buildings in the scene, and you can bring up the occlusion culling window here, like this. And then you can preview what is visible from the camera in the scene view, right? So if I move the camera, I see from the scene view's perspective what is actually visible. So if I turn off occlusion culling, there's just view frustum culling, right? It's just culls everything that is not in the direction you're looking. And then, when you turn on occlusion culling, all the objects disappear. Now, in the new occlusion culling, it's extremely accurate. So as you can see, when I get close to that wall, the object, it's actually only rendering that wall and nothing else. And previously, to bake this scene, it took around 10 hours. There's a lot of objects in the scene. It's very big. But in the new occlusion culling system, it takes 5 minutes. So it's a completely different way of using this occlusion culling system. It's, again, seems to be the buzzword of 2011. It's using voxels. So it voxelizes all your level geometry and figures out where are the holes and where is the occlusion data. And it doesn't do any sampling anymore, which means we can actually guarantee that it's never giving you incorrect visibility data. If you sample at a very low resolution, you might not get very accurate data, which means you might be rendering too much, but that's not a problem. But it will never be incorrect. So it will never render too little, and you'll get a pop somewhere. And that's a really cool thing that can actually be guaranteed with the new occlusion culling system. So, and then lastly, we added a new feature, which is portals, which you can turn on and off. So I moved the camera in front of this wall here, and now I can turn this portal off, and now I can see through it. So it's just a good way of, if you have corridors or something like that, you can just open and close doors, and then nothing behind those doors will be visible. So again, it just helps you make your games run faster by drawing less. So the next one I want to show you is directional light maps. Can we go to the demo machine? So directional light maps, what do? So with traditional light mapping, there are two problems you have. The first one is you don't get any specular highlights. As you can see in this, it looks a little bit bland. There's no specular on any of the surfaces. The second one, if you're using normal maps to get all these little details into your scene, they're not getting picked up by the light map. So there's a solution to that, and that's directional light maps. The way they work is they essentially encode the direction from where the light is coming, and then you can take the normal maps into account when rendering it. So I'm just going to turn it on here so you can see the effect. So now you have all these specular highlights. They change as you move around, and you have all these little details here. If I switch it on and off, that's really the difference that you get in directional light maps and normal light maps. So it's also super cheap to render, actually. It's a little more expensive than light maps, but it's a hell of a lot cheaper than actually putting real lights into your scene. So it's just a really good technique to just get really good quality at a decent speed. So that's the directional light maps. And the next one I want to show you is the light probes. Because, of course, now we have all these really advanced can we switch to the demo machine? Now we have all these really advanced light mapping options. And what do you do with your characters? Because, of course, when you do all this advanced lighting, you use bounce lights, you have emissive surfaces. They're not going to be affected by the real-time lights. So you don't want your characters to stand out from the lighting that you have carefully set up. So you saw before shadow gun. Oh, I should maybe open the scene first. That would help. So here's shadow gun running in the editor. And what you can see here is if I go here in this corner here, the character is very little lit. And then I go into the light, and then he gets brighter. So, and of course, all of this is done at runtime. There's not a single light being used. So it's extremely fast to render this whole scene because everything is just baked. And at the same time, you get like all the character actually picks up. Now here, there's all this blue lighting coming from the bounce light, and the character picks it up in a really subtle way. And essentially, that just helps you put your characters really into the game and match the light maps, because it's basically based on the same light information. So, and even things like this, where you have emissive surfaces, you can see the character gets green here. And for this, we developed a very unique technique for actually sampling these things. And the way it works is using something called light probes. Tetrahedralization of the space. So essentially, you see all these little points here, and what they do is they encode the lighting information from any direction at that point, and then when sampling it, when the character is between those points, it gets interpolated between them. So if I move the character out of the green area, you can see how. Oops. Oh God. How the lighting. One sec. There. So you can see how the lighting changes subtly when you move it around. The great thing about it is that it's extremely fast. Unlike in previous solutions, light probes were something that you can really only do on high-end machines. But with this technique, it's cheaper than even rendering a single light. So it's an incredibly cheap technique. It makes your scene look exactly like your light maps, and you get bounce lights and all the advanced lighting effects for free. And you can still combine it with really advanced shaders. Like this one uses a BRDF shader, it uses normal maps, and you can integrate all of that with the light probes. So it's like a win-win-win situation. Let's go back to the slides. So, well, I guess we have been working on something here, right? So the next one I want to show is gamma correct rendering. Let's go to the demo machine. In this scene, we have this head, and it's a very good example of the problems you get with our old rendering pipeline, and which is what usually game engines use to render their scenes. So with the new technique, we have gamma correct rendering, and what that means is that you're actually performing all the lighting calculations in a linear space, and then after you have done all your calculations, you transform it into the gamma space, which is what the monitor uses. And the difference is pretty obvious. So you can see here we have this color space property introduced now. So it's something you can choose on a per project basis. Maybe you don't want to upgrade your project to it, or maybe you do. But you can just switch it live like this, and you can really see the difference. Now, here you see you really don't have these blown out lights, yet at the same time you can have specular highlights on it. But it makes it a lot simpler to avoid sort of like this white wash of all your surfaces when things get bright. And it just, at the end of the day, it just looks a lot better. It's a technique that has been used recently in a couple of games like Halo 3 and Uncharted have been using it recently, and now we have it in Unity. It's something where you have to retweak some of the lighting that you set up in your scene. You'll have to tweak some of the colors for it to look really nice. But once you do it, it usually looks a hell of a lot better than before. Let's go back to slides. So the next feature we have is HDR. And essentially with HDR, you get this really crisp rendering. You have 16-bit float buffers to store all the lighting and color information. And image filters can run in HDR mode. You can, essentially, you just get this really, really crisp, high-quality look when you're running in HDR mode. And it just looks really beautiful. The next one is we added a GPU profiler. So when you're profiling your scene, we always had a CPU profiler. And the CPU profiler was really helpful for people to figure out what is actually slow. And with the GPU profiler, we're doing the same thing. So you can see on a per object basis, how much does this specific mesh with this specific shader, how much does that take on the GPU? And you can really, you can see it on an overview level, like with the CPU charts, but you can also really drill down on a per object level and just figure out exactly what it is. Like maybe there's one object in your scene that has a really expensive shader, and this one lets you really figure it out where it is. There's this hierarchy view. You can select the object, and then when you found the object, you can select it in the profiler window, and it will select it in the scene, and you can start editing it and tweak things to make it faster. Really cool feature. And then we spend a lot of time really improving performance in Unity. You saw the LOD scene that we made, 20,000 buildings with a scene with 70 million triangles. That's something that wasn't possible before in Unity 3.4, and now it just runs really fluid. So one of the most important ones we did to optimize performance is our new multi-threaded renderer. So with that, you can essentially get something between, like you will get up to a 2x performance increase depending on your scene. There's a new memory allocation system which is really good for avoiding hiccups. Sometimes we had a couple of hiccups in games when you're doing a lot of dynamic stuff, and now all of that is gone. We just moved to a really cool new memory allocation backend. And then we just did a lot of overall performance optimizations that just make Unity run a lot faster. So out of the box, if you just open a project with Unity 3.5, depending on your scene, you'll get somewhere between 2x and 3x performance improvement. Or like, it depends on the scene. Sometimes you'll not get that much. Maybe you'll only get 10%, 20%, but in some scenes you actually get up to 3x. And the last one I want to show you a demo of is our new particle system. So can we switch to the demo machine? Okay. So this effect system is completely curve-driven. So you have exact control over all these parameters. There's around 100 parameters that you can tweak. Anything from sizes, which are completely curve-driven, to colors, which you can tweak in a really nice gradient editor, to rotation of particles. And you can even draw velocity curves, so you can really control like how your particles flow through space. It's really pretty amazing. And then we spend a lot of time really trying to nail how to make those editing tools for it be completely amazing. So one thing we have as well is mesh-based particles. So I'm just going to turn those on. And of course, if you want to, you can just make them cast shadows, because it's just using the normal material system. So the really cool thing, though, is how you edit these things. So at any time, I can just pause the particle system, and then I can start tweaking things. So let's say I want to see the curve for the scale of these particles. So over lifetime, I'm now modifying the size of these particles. So I'm just going to add a new keyframe here, and then you can see here, I can just live edit these particle systems without having to wait for it to re-simulate, which is what everyone else is doing. But you can just live edit all these changes, and you just see what it does exactly at that frame. And if I want to, I can scrub in time, so I can go back and forward and just edit things some more, like just change things at the beginning of the curve. I make things bigger, and then they get smaller at the end of their lifetime, and so on. So all these things, you have a ton of options in there. Like, for example, if you want to tweak the world space, like the velocity over lifetime, so you can move these particles around on a curve. And yeah, it's just like you have a ton of options with this new particle system. There's mesh particles, there's sub-emitters where you can sort of like make firework effects. When a particle dies, it can spawn other particles. And it's just a really cool editing tool that works really well for really awesome particles. Slides. And then we just have a lot of other features that we added. So we have multi-editing. A lot of people have been wanting us to do that for a long time, and now it's there. We added some new move tools. So we have this planar move tool where you can move objects much easier on just like the different axes. We have a new prefab system. With the new prefab system, you can add components to instances and remove components from instances without breaking the connection. Sounds like nothing, but it's really useful when you're in a production. We have microphone and webcam input built into Unity. We have it working across all platforms, so it's working on iOS, it's working on the web, it's working on the PC, on the Mac and Android. Then we have a lot of smaller features in the editor, like, for example, finding scene dependencies. If you want to know which scene is actually using this texture, there's just a menu item that lets you select that. And then we have direct access to audio buffers. So if you want to really do really detailed effects, if you want to do a game like Harmonix does with Rock Band or so on, you need these low-level accesses to the audio buffers and also to filters, so you can do all these things at runtime dynamically. And that's the features we have for 3.5, and we're working hard on shipping that as soon as we can. We are about to go into beta with it, so all the features are pretty much done at this point, and we just need to spend a lot of time polishing and making it really kick-ass.
You know, the problem with new technology is that, you know, after you have it, you don't understand how you lived without it before. Your problem now is that you don't have this yet, but you've seen it, right? So I'm really sorry that we can't deliver this today. We are working very hard, and yeah, like Joe said, you should have it, you know, soon. So this is almost the end of the road. We have our guest speaker, David Breivik, in a second. But first, I'm going to ask Lucas Meyer, who is one of our lead developers, to come on stage and show us some of the work he's been doing.
Hi. What a list. Whew. So in addition to all these features that we've been cooking up, there's also some very interesting things happening on the distribution platform side. Very soon, Adobe will release a version of the Flash player that adds hardware-accelerated 3D support. When we heard about that, we knew that many of our users would want to target that platform. And when we know that many of our users want to target a platform, we want to be there for them. So we started an investigation. We set out to figure out, like, how can we have Unity help people target this new Flash 3D platform? And we didn't really know where we were going to end. However, today we would like to show you what we've been cooking up and what we ended up with. So what I'm going to show is a game that's called Angry Bots. It's the game that you get when you download Unity. It's a game that you can play on the App Store or on the Marketplace. It runs on all our consoles and on all our platforms. Here we go. Could I get the demo machine up? Here we go. Ooh. So this is the game, as many of you probably know it. Gameplay is exactly the same as it is on iOS and on Android and all these other platforms. Ooh. And it's running in your browser as a Swift file. So I can't say that often enough. This is a Swift file running in your browser. There is no plugin install required other than the new Flash player. And obviously, we are very excited about that. Okay, I'm not so good at it, so I'm going to close that off. There we go. So not only can you use Unity to target this new Flash platform, you can do it by using the exact same project folder and the exact same source code that you use to target all our other platforms. This game, Angry Bots, it was the same project folder that we use when we publish it to the App Store or when we publish it to the Marketplace. And we think that's really exciting, and it opens up a lot of opportunities. both for our existing Unity customers, they get a new platform. And they can take their content to this new platform and reach more people and make more money with their 3D content. And also for all the Flash developers in the world that now also have this new 3D features that they'd like to target, they get a great new tool to add to their tool set with which they can make this 3D content that their clients want them to make. And when they do that, and they have something successful, they can even get that and take it to all of the platforms that Unity supports, and we're very excited about that. So our development team is working very hard to get this in your hands as soon as we can. It's not quite there yet, but as you see, it's pretty much getting along. We're extremely excited to see what you guys can do with it. I can't wait, so I'll go back and finish it.